What is it non-trivial playbook or things that you've understood from SpaceX? And what I mean by non-trivial is anything that's beyond, hey, usability is key, manufacturability and simplification. What is it that, behind the scenes, given your experience, you can give us as a tip?
One of the big philosophies that I took away from SpaceX was the only laws cannot break are the laws of physics.
So what's been your journey with regards to fundraise? Really talking about what's the founder experience when explaining this to investors. Where do you find investors that can understand this vision? What's the learning from this fundraising journey?
Every venture capital firm that we brief, I've never had somebody say, number one, this is not going to work technically. And number two, I've never heard them say, this will not someday be a market. The only question is when.
What's your advice for people building hard things like you did?
Yeah. Well, first, make sure the physics works, right? Is it real?
Yeah.
And then you got to believe in it yourself.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hi, Lee.
Hi, Gabriella. It's great to see you.
Great to see you as well. We have, one way or another, we've known each other for a few years, but we only recently reconnected. Why don't you start by introducing yourself to the audience, and then we'll take it from there.
I don't know, Gabriella. I'm pretty old. This could take, the entire podcast.
What about the ChatGPT summary of Lee Rosen?
There we go. So, I served for 23 years in the United States Air Force, right out of university, where I went to the Air Force Academy here in Colorado, and was a space operator, engineer, and acquisition officer. I did multiple tours at the place where the now Space Force buys all of its space hardware, Los Angeles Space Force Base. So did multiple tours there, did multiple tours at the National Reconnaissance Office, the place that the United States buys its spy stuff, all of its space hardware for spy satellites and things like that. And also had the opportunity to serve in the kind of the classified world for offensive and defensive space applications. And really had the privilege to command at both launch bases at Vandenberg, now Space Force Base, and Cape Canaveral as well. And that's where really the whole thing got started as I was a colonel commander at the Cape, in charge of the launch group there. And my big 4-star boss said, hey, President Obama wants to come down and understand more about launch, and he's going to announce this commercial space initiative to launch things to the International Space Station using private companies. We should give him a tour. And I'm like, yes, sir, we should give him a tour. Where should we take him? Well, let's take him over to see that beautiful new Atlas pad. That'll be great. He's like, no. How about those new guys, SpaceX? And I'm like, oh, sir, if the president were to fall in a hole or they blew something up, that would be bad. That would be career limiting for both of us. So maybe we shouldn't do that. And he's like, no, it'll be fine. So we got to take President Obama over to Pad 41, the SpaceX pad. Pad 40, the SpaceX pad. And it was kind of a brand new pad. There wasn't really much there. There was this hangar that had a couple of cranes in it. It was actually a fake rocket that SpaceX brought in on the pad for the occasion. And just waiting for the president to show up. It was pretty much just me and Elon. And this is before Elon was like Elon, right? In the hangar talking about things like, you know, what do you do with the rocket after you launch it? Well, it becomes a reef for the fish, of course, and things like that. And started talking about things like, landing rockets and, how would you land a rocket? Why would you throw a rocket away? And things like that. We started talking about wanting to go to Mars. I think is the best quote I've heard from Elon is he wants to die on Mars, but not on impact. But
Which is still very hard to achieve.
They're still very hard to achieve. But in any case, we got to kind of hang out for a couple hours. And it was great conversation, and it kind of changed my life because at that point, in the United States launch industry, there had been a consolidation between Boeing and Lockheed Martin. The prices had gone up. We were able to get less capability on orbit for our warfighters and national decision makers because of that price. There was no competition. All of the launch industry had pretty much been offshored commercially to our really good friends in Russia and the Europeans, the French, pretty much. So the U.S. launch industry was really struggling at the time, and SpaceX seemed at that point to really be the only potential alternative. And I think on that evening, I talked to my wife and said, "I think this guy's got something. They may be small, but this could be really, really big." And decided to retire from the military at that point. I had served for over 20 years, and not long after that, interviewed and then was accepted at SpaceX. Started out there as the site director at the brand new launch site, Vandenberg Space Force Base, then Air Force Base, and basically took this Titan IV launch pad. Got to pick an amazing team of folks to go build this launch pad, and within about a year and a half, we had a brand new Falcon 9 and Falcon Heavy launch pad from the rubble of this Titan launch pad that I had done in my younger career, which was amazing. And I've never been on console before where you launch the rocket and everyone is in tears, right? Because this was such a monumental achievement, and we had poured, basically 2 years of our lives into making this happen. And when it went off on the first try successfully, it was an amazing, amazing day. I got to be at SpaceX, after that launch. Elon asked me to come down and run launch operations for a number of years, which I did, and served under him and Gwen Shotwell, another amazing leader. And we can talk about Gwen too, but did that. Also got to run our mission management group, which basically did all the integration of customer payloads on board Falcon 9 and Falcon Heavy. We also had the Dragon operations group in our directorate as well. So flying the Dragon spacecraft for cargo missions, and then eventually training the astronauts and flying 22 good friends into outer space. And it's a wee bit of pressure when you have to look, the families in the eye and saying, we're going to bring mom or dad home safely to little Johnny or Jill. It's a lot. It was a lot of fun, but it was also a lot of pressure. And I enjoyed the heck out of it. And we got to do some really historic things for human space flight back to the United States, which I think was also really important. So after a long time and after COVID and stuff like that, decided it was time to do the next thing. And my wife and I decided we had never had an overseas assignment, and our daughter was going to school in Scotland. So we moved over to Edinburgh, Scotland. I was helping out a small launch company there for a little while, and thinking about kind of the next thing and some of the constraints that we had, overcome at SpaceX. Like, now, back then, launch, or back in the early days, launch was expensive, and it was always late, and, it wasn't reliable and things like that. Now launch is everywhere. It's ubiquitous. It's on TV. It's, relatively cheap. All of those kind of things that we had hoped for came true. I'm doing this call over Starlink. For $100 a month, you have 250 megabits per second anywhere on the planet, and we got to launch, over 1,000 Starlinks. So that constraint is kind of eliminated. And then you start thinking about other constraints in outer space, and there are a lot of them because it's a tough operating environment. In my estimation, the next big one we have to overcome is the size of things in outer space, right? Because everything in space is relatively tiny compared to a terrestrial application. Like you would not build a house in outer space that's 30 feet long and 10 feet wide. It makes absolutely no sense, right? So why do we do that in space? We've been doing it the same way for 70 years. You build something on the ground, you cram it inside a rocket, and you launch it into outer space. And there's no way to achieve scale when you do it that way, right? And I had met these two guys, Dr. Vojta Holub and Sebastian Estrada. And after I had launched SpaceX, they kind of thought were stopping me. We had a guy that kind of knew the business side. We had Vojta, who's a technical genius, and they didn't really have a space guy. So together, we kind of put together this company. It had been formed a little bit earlier, but from the early start, we decided that bringing scale was a really important next step, and kind of that was the real birth, in my estimation, of Think Orbital.
Yeah, no, I
told you it would take a long time.
it didn't take you compressed it as much as you could. I know your story, and you really did. And it's funny enough. I want to get back, later on that story of you talking to Sebastian and Vojta. I think I was actually, weirdly enough, I was there. I was on the Teams chat where Sebastian and Vojta were like, "Hey, we found this amazing space guy that you all love to meet."
Yeah.
But I love the career that has brought you here. I think it's this very episode is being recorded, but it's gonna go out the same week that SpaceX catches for the first time the Super Heavy booster. And it's just like, I think it's perfect timing to understand that this is truly happening. Transport back and forth inter solar system will be normal cargo transport within, be it a decade or two, it doesn't matter. It's just going to be extremely common. It's going to be nothing special about it, which is where things reach scale, where you don't see them. They just happen. And I love to take you back at the beginning of your journey in that military complex where you served for 20 years, you got to the rank of colonel, you were commanding the some of the bases, some of the most important places in our infrastructure in the United States. And I really want to try to understand, what is it that you see differently from the approach that we used to have? Because it's, it cannot be single-handedly SpaceX making this reality. You guys did do this, but in the end, launch was already a thing. We'd already sent astronauts to the moon. We had regular missions to the ISS. Can you give us more context on what is it that needed to be changed while you were in the military when it comes to space and anything around it?
Yeah, I think you hit on a little bit there, Gabriele, and that's making it kind of routine, if you will. Launch is certainly not an easy thing to go do. There's what we used to say, 1 million consecutive miracles that have to happen. You don't get really a second chance. So everything has to be right the first time. It's not like a car you can pull over to the side of the road and, change a spark plug or whatever. It's not that way. But what wasn't happening was, scale, right? I mean, that's really what it's all about, is scale. The number of launches so few for every launch provider that it's really hard to get good at anything, right? Try surfing. It takes, 1,000 waves before you can stand up. It really is, that cadence piece is absolutely critical to the ability to do something on a regular basis, be consistent, and then get others to realize that this is something that can become a routine activity. So I think, my first year at SpaceX, we had 0 launches. The second year, we had 2 launches. The next year, we had 10 launches. The year after that, and finally, we got to like 30 launches. I don't know how we could do any. This is crazy. And now this year, they're already at 100, and it's October, right? It's absolutely unbelievable. And, and I give a lot of credit to the leadership at SpaceX, and especially Elon, for pushing the team to make that happen, right? Through, running that algorithm that he has for questioning requirements, and, simplifying things, and eventually to add automation to the process and things like that, to make it something that's as routine as getting in your car and driving it, basically, or as an airplane is taking off, right? Nobody stands at the end of a runway and cheers every time a plane takes off or lands, right? But in the launch world, it used to be like a huge event. Now, frankly, most folks don't even know there's a launch going on, even when you live in Cape Canaveral. Right? It's crazy. So that kind of regularity, cadence, repeatability, and reuse, I think, are the things that are making those things happen. Any company that is contemplating building rockets that aren't reusable is, 2 decades behind.
Yeah, exactly. And I mean, it's just like, would you throw away a 747 once it takes off? You just can't.
Yeah.
And
How much would your airline ticket cost if you did that?
exactly.
It's crazy. Yeah.
And I love to, so the privatization of launch, has gone to an extent where the federal government right now relies on SpaceX to launch their own payloads. Most of their payloads, or some of their payloads. I know there are other launchers that are active, but there's a lot of the payload, mass that gets launched through SpaceX. How does that shift the dynamics? Do you think SpaceX is now becoming like a 6th prime contractor there? Like, is something happening in the Air Force world for which you have a lot of concentration of power towards SpaceX, a lot of concentration of market share? How do you think this is changing the vision of the military? And also, you can speak maybe of the birth of the Space Force, which is something that we have overlooked, but you said it. I think it's I don't know how pivotal of a moment you consider it, but at least to me, it's the recognition that this is becoming a warfighting domain. And to some extent, it's becoming key for national security. Not that it wasn't already when we were relying on GPS, so heavily. But yeah, can you tie together these two things?
Yeah, for sure. So I think it's really important for us to kind of look at, how the U.S. government does launch today, right? And they've got several different avenues for launches of different sizes, right? So for the big national security space payloads, the GPSs of the world, and other large payloads like the National Reconnaissance Office payloads, they rely on 2 contractors, United Launch Alliance and SpaceX, right? And there was a competition, I don't know, it was called Phase 2 about 3 or 4 years ago now, maybe longer than that. They kind of selected those 2. There's another competition that's coming up, the Phase 3, that will have 3 contractors. I think Blue Origin has a chance to be a part of that with New Glenn, right? So I think there's the large launch vehicle part of that market, and they also have a program for national security launches that are kind of higher risk tolerance and smaller launch vehicles that's run out of their kind of office in Albuquerque for kind of a responsive launch, small launch vehicle capability that several small launch providers are powering, right? Including like folks like Rocket Lab and Firefly and things like that have won government contracts to launch certain vehicles. So it's really important that the government, the U.S. government, maintains a sort of access to space, right? That's important. And if one contractor were to have an anomaly, it's good to have another contractor or two there to pick up the pieces, so to speak, and be able to maintain our capability to gain access to orbit. So I think that piece of it is important to have this competition, because competition drives down prices. It makes people better, all of those kinds of things. So, good luck competing against SpaceX because of the things you talked about, like reusability and the cadence that they've been able to achieve. But it is important to have other providers that are out there. Now, you also asked about the formation of the Space Force. And it's really unfortunate that stupid TV show that was kind of funny, gave the Space Force.
I loved it. It was super funny. I know it's not reflective of the serious organization, but I loved it.
But it kind of gave the Space Force a bad rap from the start, and it is a really, really important new military force, the first one since 1947 in the United States, right? So the U.S. takes this very, very, very seriously about standing up, new military branches. Now, it's part of the Department of the Air Force, much like the Marines are part of the Department of the Navy. But it is still a very important recognition that the space is indeed a warfighting medium. And much like the Navy was formed to protect commerce across the high seas and to defend the nation's shoreline, the United States Space Force has the requirement to keep commerce safe in the medium of space and to protect our assets in outer space as well, right? So I think it's a absolutely critical service. And another important part of that is they have their own budgetary authority as well. Because back in the day when there was no Space Force and the space arm was part of the Air Force, you had conflicting priorities, right? You want this many F-35s and this many GPSs. How do you make that?
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
That call, right? Because they're both super important and have to give. But by having their own budget authority, I think that's another big piece of this whole thing.
And I want to come back when we'll talk about Think Orbital. How is the Space Force in general, the federal government thinking about innovation for offensive and defensive measures in space? I think it's extremely important that people understand this. What I want to tell you right now, it just came to my mind that I should have said this earlier. The other day I was on a tram and I opened Instagram. It was kind of like, I was honestly doom scrolling for like 5 minutes. And then my feed is obviously very nerdy. And so I came up, this video came up and it was the first landing of the Falcon 9 boosters. I was like, wait a second, let me rewatch it 1 second. You were there with Elon in that mission control. And I didn't know. I think I saw that video many times before. So it was actually one of those pieces of content you just skip. Oh yeah, I saw that. But I'll tell you again. The emotion in the eyes of the team was insane. But I want to take that into what your personal product philosophy has become in building new stuff and building hard things, because that's what this podcast is about, the people that are building hard things. Because I want to bridge it with what's happening at Think Orbital. So first of all, what is it non-trivial playbook or things that you've understood from SpaceX? And what I mean by non-trivial is anything that's beyond reusability is key, manufacturability and simplification. What is it that, behind the scenes, given your experience, you can give us as a tip? Just if you were an advisor to our own small startup here at BitBuilders.
Yeah, I think we as human beings tend to over constrain problems, right? We put so many, we pile on top problem after problem, and this is why this won't work, and this is why this can't work, and there's this regulation that's piled on top of that, and there's this rule that things like that, are constraining to any technical problem, right? But one of the big philosophies that I took away from SpaceX was the only laws you cannot break are the laws of physics, right? So when you start out to solve a problem, right, think about, is this physically possible to do it, right? Do I have to achieve the speed of light to do this? Does there have to be a magic potion that's be invented to go do this? Or am I bound by physics and I can actually make this happen, right? So I think landing is a perfect example. I mean, we were told by several government entities, I won't name names, that relighting a rocket engine during, the hypersonic flow during descent, lighting that match in a hurricane was essentially right.
Well,
and I distinctly remember Elon saying, "Show me the physics that this will not work." Because here's the physics that it will work. We put, aluminum triethylfluorine into, a thread chamber with both oxidizer and fuel. It will light every single time, right? And here's the chemistry behind it. And no one could say it was physically impossible. They didn't say it was easy, but nobody could point out how it was physically impossible, right? And basically we did it. And landing that day where we landed the first rocket, the 21st of December of 2015, as I recall, because those are big days that stick out in your mind. It was a crazy day because there were 11 OrbComp satellites sitting on top. One of the OrbComp satellites was having some issues, and there was a whole thing about, can we launch today? Satellite, did we go fix that satellite? Well, that all ended up being resolved. And then during the final countdown, there was liquid air being formed inside the inner stage, dripping down towards the aviators. And we're like, oh my goodness, what should we do here? And Elon's looking at us, we're looking at him. He's like, anything that could get us up there? And we're like, well, we don't think so. He's like, let's go for it. And it was like one of those, say what you will about Elon, but Elon, when he has good data, he makes great decisions, and he is never afraid to make a decision. And I've not met a human being with more technical depth and breadth than Elon, which is, I've had some great technical mentors in the past, but he is amazing in all aspects thereof. So, we made the decision to go that night, and we're running outside and looking at that rocket. And if you ever have the opportunity to see a landing, Gabriella, I suggest you go do it, because it looks like, regardless of where you are standing, it looks like it's coming down on top of your head. I remember being at like events where we were watching a landing, and people are looking up and they like start to run away. Like, I'm like, number one, it's not going to land on your head. Number two, you running away ain't going to make sense.
ain't mad at there, dog.
If it didn't go wrong, it ain't going to matter. You're not going to outrun that. So anyway, but so I think boiling it down to the basic physics problem, and then working through those other constraints, because they're in place probably for a reason, but that's the first step in that algorithm is question the requirements, right? And all of those rules, like you can't do this because the government says so, are probably made up by somebody. And there may or may not have been a good reason why they made it. Or it may be outdated, or it maybe was somebody's pet project or whatever it was, but question those requirements and then work through them. But don't let that constrain your problem.
And I love how that is, the philosophy at Think Orbital. I know that for a fact because I've seen it close up. And I just want to point out, you can actually ask my bosses in the last 2 jobs that I've had. In both of the cover letters that I wrote for those jobs, that night was mentioned where the first booster, because I was an aerospace, I'm an aerospace engineer by background, but I decided to look more at the business side of things. The day that I watched that, it was weird because it was a mix between humbling and inspiration. I watched that happening and I was like, okay, I am so far away from having the technical requirements to help this make a reality. I don't know, it was a biased view because could have just kept studying and educate myself on it. But I realized there was going to be an entire economy. It was actually going to come out of that landing. And I was like 16. So I already understood that there was something there. I didn't really know what. And that really guided my curiosity for next years. I think I started watching the MIT open courseware physics courses. It's still in high school because I was craving to get there to actually realize, hey, how did these guys make this happen? So that night special for me too, weirdly so. And what I wanted to point out is that what you just said, there are some constraints that we think that we can never, escape. And I think this was the reason that I got interested in Think Orbital when I met one day Sebastian, the former CEO of Think Orbital. And I met him in Amsterdam in a completely random restaurant. So he reached out to me over LinkedIn because I don't know why. I still, to this day, I don't know why. And then we met up in a restaurant in some, vegan burger place in Amsterdam, had a vegan burger. And then he was like, hey, do you want to help us raise our pre-seed round? And at that point, I didn't know why I would say no to this because I had nothing to lose.
Yeah.
So, I cannot say it contributed much to the entire journey, but what I learned is the idea behind Think Orbital comes from a very simple physics problem, a very simple constraint that I really want you to kind of elaborate on. But for the benefit of the audience, payload fairings are not getting much larger over time. And we're lifting a lot of mass. I don't want to say a ton of mass because that's misleading. A lot of mass. The volumes that we're lifting, well, now with Starship, we'll see how that changes. They're actually staying pretty constant. So that constrains our ability of building larger things. We got to build them autonomously, as they're in orbit. How did that inspire, how did this physics problem, literally just like the textbook problem, inspire Think Orbital? And Wojtek in the beginning, think of that topology. Can you give us a rundown on how that happened?
Yeah, I think it kind of came from that. We call it now the tyranny of the payload fairing, right?
Oh.
And when you look at every space station that's ever been launched, it doesn't look like the future, right? It looks like something out of the past. And every science fiction movie that you and I and everyone else has seen has these huge ships in outer space, right? So, what does that? Art kind of mirrors life sometimes, right? So maybe we should make that art mirror life, and if you recall, Gabriel, we used to say around Think Orbital, you can't build the Death Star without us,
Yes.
But I mean, if you think about, a huge structure in outer space, like the Death Star or the Starship Enterprise or any, pick your Tycho station, right? You pick your science fiction. Every one of them is absolutely huge. And I think that served up really as a lot of the inspiration when Wojtek kind of came up with this original idea, that we needed to build something in space And the funny thing is, we had that idea kind of from the get-go, and all credit to Voida for coming up with a practical way to do it. But what we don't have are the tools to actually build it, right? To make that happen. And that was really kind of the refocusing in Think Orbital that I think was absolutely necessary. We went from, hey, yes, in our roadmap, we are going to build large infrastructure in outer space. But before we do that, we have to figure out what tools we need to actually build that infrastructure. We got to get good at using those tools. So we basically had to invent, for lack of a better word, much of the tools that will be used. And it turns out there's a technology that's available that was very well suited to doing basic construction. So, that's the electron beam welding that we work with. And, we took, these electron beam welding guns that are normally the size of a desk. They're huge, high power, high voltage machines, and shrunk it down to the size of a large coffee mug, right? And to make it
Can I stop you for a second? Because the two of us, oh, there it is. No way.
There it is. Yeah, a little show and tell. So it's a 3D printed version of the electron beam gun. So you can kind of see how small it is. But, with 20,000 volts and 2 kilowatts of power, I can weld and cut up to 1/2-inch aluminum. So,
oh my God. Slightly powerful. But actually, let me ask you, because we are running the risk of doing an aerospace engineer to aerospace engineer conversation. What is electron beam welding? Where was it used the first time? And, where do we get the idea that it actually can work? Let's unpack that one a bit.
Yeah. So electron beam welding sounds like it's out of the future, but, or science fiction, but it's been around since the 1960s. And it was used extensively in the nuclear industry, for, doing single pass welds of like 12-inch steel, right? I mean, it is a very effective form of welding. The biggest issue with electron beam, though, is when those electrons, number one, they don't like to be near each other anyway, right? Two negative charges want to repel each other. The biggest issue is when they hit another path to ground, like air, they are going to go anywhere other than they want them to go. So all electron beam welding has to be done inside of a vacuum, right? So the nuclear guys would take their big part, bring it over to a vacuum chamber, suck out all the air, which takes hours and hours, set up, do all their welding, and then have to repressurize and get the part out. So it's a very time consuming process to do here on Earth. So, but we know where there's a great vacuum. It's 100 kilometers from everywhere, right? And that's outer space. So it makes it really the ideal kind of tool for use in construction in space. And it makes beautiful welds. I'll show you some that we've done here in Boulder. There's some really, really nice tight welds that we've been able to do. We did it for the first time ever in outer space on the 6th of May of this year, where we launched the world's first autonomous welder in outer space. And the European Space Agency just came out with a nice report on the quality of the weld, the importance of the weld, the differences between the terrestrial samples we did for them versus the on orbit or in space samples that we got back. So that we got to contribute to science, which is amazing because both the European Space Agency and NASA have those samples and are learning a lot from those samples. But we also got to test out our technology, which was truly amazing. We've got another flight coming up here to demonstrate more of this capability. So we'll do some long form welding, a little under a meter of welding to do in this next mission. But we'll also demonstrate a couple of the other capabilities that are pretty cool about electron beam as well. So part of the electron beam system we have, has this area here, which is called the steering coil. And if you think of an old, 2 volt, 4 volt, 6 volt, 8 volt, 12 volt, 24 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 volt, old television set where you're rastering the CRT, right? You basically are electronically steering that beam of electrons by putting a charge on either side of the steering coil. And you can move the metal back and forth and actually do cutting, which is kind of cool. So you can kind of see the cuts that you can make by basically very quickly steering the electron beam back and forth and sculpting metal from side to side and pushing it out of the way. And that's the front side where the electron beam hits. On the back side, it makes a very nice clean cut, right? The cool thing is it doesn't generate any debris like a traditional cutting. You know, if you're cutting using a hacksaw or a wood saw, you know, you're flinging off debris, which is bad when it's going 17,500 miles an hour in outer space. It also doesn't generate any thrust because or very little thrust, because electrons essentially have no mass. So you don't have to hold on to the thing that you're cutting, right? So in theory, I could sidle up to you, cut your solar panels off, and you wouldn't know it until the lights went out. So the cutting piece is very important and something that we are going to demonstrate on this next mission in December that we're launching into orbit with SpaceX, which is cool. And the third thing that we're going to demonstrate is another interesting characteristic of electric beams. So when you accelerate those electrons down the gun, they're moving very, very quickly. A small percentage of the speed of light, actually. And when you slow those electrons down very, very quickly by hitting a very dense metal, they emit radiation. And that radiation comes in the form of X-rays. And, much like go to the dentist, or if you had a broken leg, you go to the doctor and they take an X-ray of your leg. Having X-rays allows you to inspect the weld that you just did, or perhaps even look inside of the object that you are directing those X-rays at. So the ability to look inside a satellite is a very intriguing possibility for both the government and for commercial applications. Like if I have an anomaly on my spacecraft that I can't figure out electronically, because that's the only data you get, if I can get a picture of what's going on the inside, imagine trying to diagnose a patient without X-rays that has a broken arm or something like that. It would be very difficult to do. But this kind of adds a whole new dimension to the military application of space domain awareness, to be able to look inside objects to determine what they're doing, what the characterization is, what the types of talent they may have on board, what the different boards that they have inside the satellite. Are they hiding something, like the Russians are allegedly hiding nuclear weapons inside satellites? Those kind of things are now enabled by being able to get an X-ray of the interior of your space.
This is incredible. What you're saying is, Think Orbital is currently building this Swiss Army knife of space. You can cut, you can weld, you can actually see, and everything, by the way, from the same, stemming from the same technology or rudimentary technology that you can miniaturize, improve, and also use data that's coming out of that. Because wasn't there a story?
If you put a wire down the center of it, you can 3D print with it too.
Obviously, because you're melting that wire and then let it deposit somewhere. So, and this is another funny story. Together with Think Orbital being, in my opinion, one of the biggest enablers in the next few years of what will be the in-space economy and conventional space, etc. Funnily enough, our first office space in Orbital was in Boulder, Colorado, in the same building, I guess the same floor as Orbit Fab, who's also looking at the other thing. So we're looking at how to, cut, move here at Think Orbital. That's what you guys are doing. And then Orbit Fab is looking at how do we keep spacecrafts refueled? How do we actually ensure that mission continuity is there? How do we go out and resurface that satellites that are so important and so expensive to replace? So what this is giving me is like, this is a huge picture of how the space economy is evolving around low Earth orbit and beyond, up to geostationary orbit, which is what, 38,000 kilometers?
Kilometers, yeah.
Yeah. And it's just beautiful how we're just still building, the tools, the picks and shovels of this.
Yeah.
We're just at the very beginning. Where do you see this going in just the next 10 years? What do you think will be achieved in the next 10 years? I think it's a really visible, horizon. I don't even want to ask you what you see in 30 years. Just in 10.
I think, so today, our current concept for in-space servicing, right, are things like orbit found, gas stations in space, right, which is very cool to be able to refuel a satellite, or companies like Astroscale that are essentially tow trucks in space, moving a space satellite from one place to another, right? But when I take my car in, I want to go to a full service station, right? I want to diagnose the problem. I might want to fill up on gas. I might want to move from one place to another. If I have a problem, I might want to have a way to fix that problem. So what we're doing is taking all of this technology that we will have demonstrated by December of this year and packaging it into what we call a Think toolkit, which is a robotic arm and the thing that's your hand, the end effector, right? And the end effector is that welding, cutting, X-ray, and additive manufacturing capability that can pretty much be integrated on any medium satellite or larger. The whole thing weighs on the order of 35 kilograms, so it's not a huge piece of equipment with a robotic arm, with a 1 meter robotic arm. We've got some partners that are helping us build that robotic arm. NASA is paying for us to go test this overall system in vacuum next summer. And then we're actually going to fly this thing. Here's an exclusive for you that we haven't really announced yet. We're going to go fly this thing with a partner. Can't say who the partner is yet. In December of next year on their host satellite, where we have the robotic arm. We're going to cut some metal, weld some metal, and then we're going to take an X-ray image of that host satellite while it's on orbit. That is going to change the game. And then we'll have this capability, and then we can sell pretty much every medium satellite or larger to have its own insurance policy on board. And for those doing rendezvous and proximity operations, to really have a true servicing capability. And that's, the next year we'll have that capability ready to go sell. We'll also be working on a long-range X-ray capability because we can produce decent X-rays with our gun. But if I really want to do X-rays over distance, I have to use a different X-ray source and focus that X-ray source. So we've got a design to be able to actually look inside a satellite 10 kilometers away to tell if there's something in that satellite that shouldn't be in that satellite, like another satellite or a solid nuclear core or something like that from distance. And obviously, I'm not going to tell you how we do that, but the physics works. So that was the first principle, like we talked about, is we can make those physics work. We've got a design for making it. So that's our second product. We call it ThinkX, a dedicated X-ray capability. And all of these capabilities, we've got to get really good at when we start building that large infrastructure in space. And, we plan to have the first kind of node of somebody else's space station. And we're working with all the commercial LEO destination providers that NASA has to potentially put a node on their space station, the node being built in our space to give them additional volume that we call the Think platform. So that will first be part of somebody else's space station, eventually be its own free-flying space station that you may have seen pictures of and things like that. That's what I think in the next 5 years. I'm not even talking 10 years. I'm talking 5 years. By the end of the decade, you will have an assembled structure in outer space.
And I think every single founder that's listening to this is asking himself, how do you even fundraise? how do you how do you tell the story? Because to me, it sounds so logical. Because I've worked on the very first pitch deck of Think Orbital. I hope you guys are still using the fonts. I was very proud of the fonts. The thing is, how do you fundraise for this one? So, what's been your journey with regards to fundraise? Really talking about what's the founder experience when explaining this to investors. Where do you find investors that can understand this vision? What's the learning from this fundraising journey?
Yeah, the fundraising journey. You said founders think about it. I think about it every second of every day because it's still raw. And it's interesting. Every venture capital firm that we brief, I've never had somebody say, number one, this is not going to work technically. And number two, I've never heard them say, this will not someday be a market. The only question is when, right? And I get it, right? And I have the same argument when we were at SpaceX. There's no commercial launch market. Russians and the French have it locked up. There's very few satellites launching other than military satellites and communication satellites. The government's never going to work with you because you're not Boeing or Lockheed, right? So again, all made up bullshit, for a lack of a better term, then you cannot let constrain your problem, right? So we look for venture capitalists and partners, that understand that this vision is absolutely achievable from a technical perspective. We've got the right team in place to make that technology happen. And we're absolutely demonstrating it in space because you are not a space company until you demonstrate things in our space. So we've got to launch this. We had a launch in May. We've got a launch in December. It was supposed to be earlier. There's been some things, there's going to be technical struggles that we have to overcome. SpaceX has had their share of issues as well. So, still within a couple of months, we will have the second launch. Next year, we've got a third launch. And proving that capability works in orbit and being super capital efficient. I don't know too many space companies that will have 2 launches on a pre-seed round of $3.5 million, right? That's, and we have to be scrappy. I think a great example of that is one of the vacuum chambers that we have. We bought on eBay. This is a meter by a meter vacuum, big, relatively big size vacuum chamber. We bought it on eBay for $979. It cost us $1,200 to ship it here from California, so more than the actual cost of the vacuum chamber. And then we put a couple of grand into it, and now we've got $1 million thermal vac chamber that's working great, and we spent a couple of grand. So I think you have to be super scrappy. And again, another lesson learned from SpaceX, right, is aerospace has traditionally been equated with it must be expensive and it must take a long time, right? That's not true. It doesn't have to be that if you put your mind to making it not that way. And that's something that I have to because every VC I talked to said, "Oh, you're going to be doing funding rounds the rest of your life, or this is you're going to be having Series F rounds at $150 million and stuff like that." I'm like, I don't think so. I don't think it's going to take that much to do this. And they're like, you're wildly optimistic. You were trained by the greatest optimist in the world, Elon Musk, those kind of things, but I'm telling you, it is absolutely possible to do this on not a lot of money, and make things happen. We're proving that on a day-to-day basis.
I love that the argument is, hey, you'll keep raising. Is that the argument that should, change my willingness of doing this? I don't think it will. But I think
we spent a lot of time on it, Gabriele. It's we're in the middle. We did a little bridge round just to get us a runway, so we don't have to be desperate in the seed round. So did a little bridge round that gives us some good runway. Where we've got a bunch of seed money lined up. We're looking for a lead investor, and the lead investor that can take a good portion of that round. and, convincing people that, again, they're going to get a return on this investment, hundreds of times what they put into it. It may take some time for the market to develop. And yeah, it's kind of a double risk, right? Because any venture capitalist not only has to bet on us that we're going to be successful, they also have to bet on the market developing and when that market's going to develop, right? So you have to have the right type of attitude from a venture capitalist. This is not like a software that, in 2 years, you're going to be generating a huge amount of revenue. But in 5 years, I can see us generating a lot of revenue. In 10 years, a crazy amount of revenue because, we had these early people that believed in us, believed that this is an important market. Again, nobody says this market is not undeveloped. It's just a question of when.
And I actually work at a firm, Fundamental, where we place a lot of importance on market dynamics and understanding very, very, very well what is the market that you're going to be faced with, because we invest mostly in construction technology, which, as you know very well, when you build that launch pad, I think you've had your fair share of understanding of what a general contractor does and what the big issues with handling so many subs and understanding how do I make margin while others make margin, etc. It's a really complicated one. And I think I really want to try to apply this with you to the space industry. If you have to give us a space industry 101, space economy 101 lesson, right? What do you think will be the key catalyzer that will make access to space has been solved to an extent, right? It's going to get more and more, less and less bottlenecked. And so you're going to have more and more stuff in space. Nice. That's great. But that doesn't make it a business model for the people that you're launching on. You're probably making money by giving that ride, having people hitch a ride from you. But then what happens up there? What do you think are the avenues that are going to open up more and more to help the space economy develop further?
Yeah, I hate to say it, but it's the government, right? And if you look at any, and particularly the U.S. government, right? There are other governments out there that are investing, but the scale is different. And tight free world here, not China and Russia, but capitalist economies. So in any case, I honestly believe the government has got to get behind, these new missions in outer space, like space servicing, like in-space assembly, manufacturing, and construction, like new ways of doing space domain awareness to, defend the high ground of space, right? We stood up the Space Force. We got to give the Space Force modern tools to be able to defend the high ground. And until they start making real investments in those areas, it's going to be tough sled. So, the reason we're doing the X-ray piece is because, number one, we know it's important for defending the high ground, but we also know there's going to be an immediate government market for that. Same thing with the toolkit, because we know that space servicing is important to the government for dynamic space operation. And they're going to want this capability to service their own satellites, to, do offensive and defensive counter space things to the adversary satellites, right? And you look at some of the companies that have been successful in that sphere, our very close friends at True Anomaly are there, our friends at Orbital, Northrop Grumman, folks that have launch capability in these areas are very successful, but they're mostly successful because the government is starting to take an interest. And, we just won our first phase 2 contract with the government on the X-ray capability. And that shows that the government is becoming committed to these things. And, I think they are starting to, the biggest struggle we have is getting the government to understand what's within the realm of the, right? Because it's hard, because the traditional military contractors don't necessarily want to expand that on, right? They've got a good business where they are. They are not able to flex and react as quickly as small, nimble organizations are to meet the true needs. So most of the folks in the government don't even know that, big infrastructure in space, what, the space station? No, there can be more than just that. And it can be used for military missions. Like, I think a great example is this whole emphasis on rapid and responsive launch, right? Where, our friends at Firefly, got a call up order and they were able to launch a satellite within a couple of days, right? Which is a great capability to have. But, if the Russians, God forbid, were to come across the Ukrainian border into Poland, we don't try to fly all the tanks over to Europe, when that happens. We don't wait for that to happen. We have stuff pre-positioned, in kind of a warm storage, ready to go in the event that something bad happens, right? So the thought that you're going to be able to launch capability to replace something that was taken out on orbit or provide additional capability is kind of an antiquated thought, right? If I can pre-position things in large storage depots on my timeline versus my adversary's timeline and deploy them really quickly, man, I could really change that whole operational timeline and loop that, getting inside my enemy's, what we call the OODA loop, the observe, orient, side or side act loop, right? Where you're trying to think faster than your adversary. But that's not even in the psyche of folks that are doing the strategic planning in the Space Force, because the capability doesn't exist. It's the thing of science fiction. Well, no, it's not. And the missionary work that we have to do, we hired Colonel retired Justin Chandler, who kind of runs our government relationships and Justin and I are on the road all the time talking to senior leadership in the military. You've got to expand your aperture a little bit to say that there are new capabilities available that can change the way that we do, essentially warfighting in space. And they're not different than how the government does warfighting terrestrial. They're just applied in a different manner, right? With different technology. Sorry, long answer, Phil.
No, extremely well thought of. Actually, it takes me back to, this is not only happening in the space domain. I think it's also happening in the general space that, venture capitalists today in the US would call defense tech. I think it's a super wide term. It just in general, even in those capabilities that already exist are being modernized by, basically former tech company operators that are working to, modernize what the military industrial complex looks like in terms of supply. So you have, companies like Anduril, which, the story, the jury is still out. None of these companies have already reached a clear mark of success. But what you can see is that there's an insane willingness from the US government to slowly roll in new technologies that are replacing, risk adverse prime contractors that have been, grabbing all the contracts for the bigger part of a century. And so this is happening at a scale that's actually pretty frightening for them. Obviously, it's pretty exciting for people working, in the innovation ecosystem and in the startup ecosystem. But what it signals, I think, is that geopolitical issues are actually prompting innovation here. And it's pretty sad because the geopolitical issues, unfortunately, are not the happy ones that you would want. But on the other side, you're generating a huge wave of innovation that to me resembles 1968 and 1969, where we were building stuff for responding to geopolitical issues. And we advanced, for example, computing, materials, simulation, so much ahead that we are still reaping the benefits of the Apollo program. And now, instead of happening within the bubble of NASA, it's probably happening more and more and more in the tech hubs. I think it's just a reflection of knowledge being spread around so much.
Yes.
I see this as great times for the advent of technology. I think space has always led the way.
Yeah. And, I think the government is starting to see the light, but they're also kind of, in some respects, talk out both sides of their mouth, right? They say, we want to take advantage of commercial capability, right? Well, show me the commercial servicing market. Show me the commercial large infrastructure and space market. It just doesn't exist yet, right? So if they really want a commercial capability, I look at like commercial imagery, right, which is huge right now, and it spawned a bunch of other different industries from commercial industry. And for years and years and years, taking images of Earth from outer space was the province of the government, right? It was in fact illegal to get better resolution than the government, right? But now, all of these companies are getting commercial imagery from outer space, whether it's, electro-optical or synthetic radar. There's companies that are doing manipulation of that data, things like that. Just because the government started that market out, created it, and then people saw that it was super useful and had other applications. I think something very similar has to happen in the, in space assembly, servicing, and manufacturing world and construction world in space, that the government has to kind of lead the way to get it to have a commercial capability that it can go by, then go by. How the government relies, commercial imagery as much as they rely on the indigenous industry or imagery that they produce.
Yeah.
It's not.
And if you were to, overstep, right? You gave me a really good, realistic view of what the market is looking like. And you said very, like, bluntly, hey, it's the government. That's the market. That's, the willingness to pay of the government agencies. You can put it on Excel, sum it up, and put out a report. This is the market for space to an extent. Because you have Earth observation, I think is very commercialized. But what is it of the built stuff? So we're talking about physical products that will be the first product to be sold in a commercial market. There's to give you and also to give the audience a hint. I don't know if you think it this way. We haven't rehearsed this, but some may think that pharma in general, with the benefits of protein crystallization in space, may be one of the first markets to have one, small light to commercialization. There's a few companies like Lambda Vision that want to grow retina in space. They've actually done some experiments on the ISS. And there's a big bottleneck actually that Think Orbital, is still in the long term trying to solve, but also vast in gravitics, where the ISS did not provide the research platform that was needed to develop these products to the scientists who wanted to run this research. Now that we have more access to space, the argument goes, hey, you not only can develop more, you can also manufacture, ship back to Earth. They have high value products, right? Do you see that as an avenue? Yeah. And yes or no? And that if you do and if you don't, what else do you see as a possible avenue?
No, 100%. I think, we're very close to our friends at Varda, right? And Varda is showing that, producing, a specific pharmaceutical in outer space is fine, right? I think the drug is called Keytruda, right? And talking to Will Brewery, they're excited that they can do that and bring these life-saving pharmaceuticals back down to Earth. But what they lack, and what even these other companies, the Vasts of the world and others, is scale, right? They can only get as big as the size of a fairing, right? And even though fairings are getting bigger, they can't scale. And I think that, in my mind, is the missing ingredient, is the size of infrastructure in outer space to do these things. And obviously it's a chicken the egg kind of problem, right? You have to have the technology, and you can't really develop the technology unless you have the scale and willingness to invest in a large research facility or a large production, right? And that's why this business that we have has to be supplemented by other things like servicing missions, like X-ray missions and things like that. until that market really gets heated up. I don't think that's decades away. I think it's years away. And again, it's a missionary work to show people that this is absolutely possible. And then companies like Varda are showing that there is economic viability. Lambivision is another, right, to produce, retinas in space or fiber optics in space or new crystals and compound factors. Our friends were very close with Space Pharma, right? They've flown to the International Space Station 6 or 7 times now. And are producing new chemical compounds and pharmaceuticals that no one has ever done before. But what they don't have is scale, right? And the ability to build that scale will spawn a whole new industry. You can't tell a VC build it and they will come, but I'm telling you, build it and they will come.
No, but exactly. I think it is one of those sentences is really controversial. Like it's really, you really have to put it into context. For some things, I think it's doable to think about this. I think there's the argument also of depending on the potential size of the market that you're building, you're calibrating. Hey, how much should I hope for them to come? Right, and I think the bet, the expected value, which is just the sum of the probability of failure times the outcome. And probability of success times the outcome is just huge. The expected value of this,
Right.
It's really huge because the even if the probability of success of failure is 99.9% with a zero outcome, you can actually multiply it for the outcome of success, and it's just incredibly large. Obviously, the market. Yeah, go ahead.
No, I was going to say that the good news is that we're also seeing Moore's law in effect on the number of objects in outer space. Right, every 18 months to 2 years or so, the number of objects in space is doubling. Right, and there's some that are small, but most of them are medium sized and larger. Right, even the new Starlink satellites are fairly good size. Right, over 500 kilograms. So if you think about the sheer numbers, I think our projections show that 10 years from now, we'll be launching on the order of 70 to 100,000 objects into space a year, right? It sounds like a crazy number today, but if Moore's law continues, which we've seen it happen over the last few years, then that is a realistic number. So if there's 100,000, just say for ease of math, things in outer space, and I get 1% of that business, man, if I got a toolkit on 1% of those, holy moly, I'm a unicorn times 10, right? I mean, that's an amazing opportunity that's out there. And that's the kind of thing that you have to show the VCs that I don't need the whole space. I just need a very small percentage of it to make the toolkit viable, to make this X-ray thing viable, to make the large infrastructure in space viable. They're not huge numbers, but they're huge numbers of opportunities that are out there. And you only need a small slice of that big pie.
And for that to happen, I think stories like that of SpaceX have shown that the best ingredient, the most important ingredient, is capital efficiency. If you want to show, in that vulnerability window that you're running as a startup, that you can make it, you just need to be scrappy. You just need to buy vacuum chambers on eBay. And by the way, who the hell sells that? Like, who was selling it? Can I, do you know?
It was in the scrapyard of the Lawrence Livermore Laboratory. This thing had sat outside for probably 5 years. So it wasn't pretty, but it's pretty now. We cleaned it up and it works great. So, I think it's those kinds of things, that you just gotta do. Like even this beautiful office that you see that we're in right now, this place is frankly a dump when we took it over, but we spent many, many weekends tearing down walls, painting stuff, putting in windows, making it livable and nice. And don't look too closely because We did a lot of the finished work ourselves, but it's a very functional and nice place, right? And we didn't have to spend $1 million. We spent, a couple $1,000 to make it look really great. You got to do that if you hope to survive, because in this world, it's you're capital efficient or you die, right?
And on that remark, I kind of want to ask you, as a closing remark of your advice to founders that are building extremely hard things, that have, the fundraising market might be against them. Their pitch deck may just not come across as they hope it would. And they're just building an hard industry. What's your advice for people building hard things like you did?
Yeah. Well, first, make sure the physics works, right? Is it real?
Yeah.
And then you got to believe in it yourself, right? And if you believe in it, then you can convince other people. If it's real and you got and you believe in it, then anything can really, right? And I think those two things are super important to the whole thing. And then, as you said, other ingredients like capital efficiency, like having an amazing team of people. I mean, we got some of the best in the industry here. We're very, very fortunate. We're not a huge team. Yeah, we got 13 full-time equivalents now. But that's the other thing. People throw people at problems, right? I'd rather throw a brain at a problem than just sheer numbers of people. So if you get really smart people working very, very diligently on problems, then that's another important ingredient. It's just not, I need another body. No, I need the right body with the right brain in place to make stuff happen. So I think those are important pieces of the whole thing.
But believe in your idea, check the physics of it, build an awesome team, and be scrappy.
Yeah, I think that if you boiled it down, Gabriella, you got it.
Sounds like a plan, I guess. Well, Lee, thank you so much for being with me today. For me, it's really been extremely special to hear from you after 3 years, and just see how much progress you've made. And I think this will be a super valuable conversation for the founders and the people in the industry that are listening. And I think really much for everyone is one of the most applicable episodes that we've had on BitBuilders. Thank you so much for your time. I'll let you go back to just easily build, welders for space and X-rays to detect nuclear weapons.
Thank you so much, Gabriella. You were in on the ground floor of it, and without you, we couldn't be where we are today. So thank you so much, and to all those out there, believe in your dream and make it happen.
Thank you, Lee. Have a great day ahead, man.